Elva ma'am.
Hello, ma'am. Good evening.
Good evening, sir.
A very good evening to everyone gathered here. I am Elva Selson, Assistant Professor in the Department of Analytics, PGDM, at SCMS, Cochin School of Business. With great pleasure, I extend a warm welcome as we commence the second day of our AICT sponsored 6-day online faculty development program on building predictive AI models for route optimization and emerging technology practices in smart manufacturing, organized by SCMS Cochin School of Business. Yesterday, we set the tone for an insightful learning journey, and today we continue with equal enthusiasm, bringing together experts whose academic depth, industry experience, and research contributions truly enrich this FTP. As we continue from where we left off, today's session will take us further into the core concepts, helping us gain a deeper and more practical understanding. Together, the diverse academic rigor of Dr. Ramesh Kumar and the industry rich experience of Mr. George Joseph Kalel create a balanced and dynamic learning platform on the bridges theory with real world execution. With great respect and anticipation, let's begin today's session. I invite our resource person, Dr. Ramesh Kumar, to lead us into the next part of his enriching learning journey. Introducing our resource person for today. Our first resource person for the day is Dr. Ramesh Kumar, Assistant Professor in the Department of Operations at the Amirda School of Business, Coimbatore. He holds a PhD in Operations and Supply Chain Management from IIM Mumbai and a master's degree from NIT Jamshedpur. Dr. Ramesh has previously served as an assistant professor at IIM Mumbai and worked as a research intern at Intel Technology Private Limited. His research focuses on digital twins, simulation modeling, and mathematical models related to supply chain and transportation, perfectly complementing today's theme. In fact, he is an operations and supply chain expert. Welcome, sir. We are waiting for your session.
Yeah. Thank you, Elva.
Thank you, sir.
So let me share my screen. Okay. I hope my screen is visible. Can you please confirm?
Yes,
Yes,
sir.
sir.
Yeah. Thank you. So thank you, everyone, and welcome back to the second day of the faculty development program. I hope in the first day you have enjoyed the sessions, and in continuation of that, as a part of the session three, where we are going to cover emergence of the smart technology in the last mile delivery. So in continuation of this topic, particularly where we have yesterday left, and basically if you talk about the yesterday session where we have set up the tone of the fundamentals and the basic of the last mile delivery, how the last mile delivery will work and what are the different component and what are the operational process. So my talk out basically focus on the basically or the process, the operational process. Then we seen the what are the different challenges was there, and then we'll talk about the different emerging technology, how last mile delivery can be supported. So these are the way where we have summarized the yesterday class. Let's begin today class. So we'll again back to the agenda. If you look the top three agendas of we have covered yesterday, where we'll get the all basic kind of things particularly. So today's session is very interesting in terms of the deployment, in terms of you are seeing the cases. So we have take the four cases of here. If you talk about the overall of these cases, so case number one and case number three, which is basically talking about the truck drone delivery system, and case two are particularly talking about the only drone system. So these are the two mode of transportation where we are using drone as well as the truck. Okay. The fourth case, which is very interesting in terms of food delivery, where we have used the e-bike and the motor scooters. So these are the two kinds of the delivery vehicles we are using for the case 4. So these all cases we have covered by using the some packages which is called simulation and somehow the optimization tools in terms of some, if you are going in very customized way, then it is optimization. So I am using the first three cases for the any logic, and the fourth cases we are demonstrated with the help of the any logistic package, right? So these all packages are based on the Java. Those who are expert in Java, they can customize the problem based on that. So let me start where we study. Study. I think we have somehow will give the glimpse of this truck drone delivery system of this particular case of the Pune. So let me jump again to the start from the what kind of models we have did here, and what are the models input we have required. So if we simple talk about the what are the input data we have required, so where the input we required in terms of the vehicle capacity, delivery locations, then we'll talk about the customer orders, delivery, I mean service areas, and then we'll talk about the delivery time and the what kind of speed of drone they have. Even again, lot of assumption we have considering. We have not considering here what kind of drone we have considering, right? So we have generic model we are trying to develop and through using the simulation any logic. And then what are the expected output in terms of KPI we are expecting, where how many trucks, drones, number of drones we have, and how many number of trucks are there, how many services we have done by the drone, and how many services are done by the truck, and how the synchronization happen, and what are the transportation route we have captured through the drone and the truck. So these all kind of KPI we are going to capture by develop the model. Okay. So this particular case I have considered on the Pune based, right? This is Maharashtra Pune based case where we have considered 50 customers, and this all customer has placing the order, and where we have delivered this order through the truck and the drone both. Okay, so let me go through the model particularly. And before model, I wanted to show some customer data. Yeah. Hope I'm audible here. Perfectly fine, right?
Yes, sir, you are audible.
Yeah, okay. Thank you, ma'am. So these are the 50 customers which we are going to serve for this by using the truck drone delivery system, right? Where if you look, these all data of the longitude lat. So in terms of the customers, we require longitude, latitude, and how many orders and what are the orders are there, which time they have ordered. So that all kind of the factors we will look into the model. So I'm opening here is the any logic software particularly where if you talk about this, this is one of the very powerful simulation software where they cover the all kinds of almost simulation. Like if either you talk about discrete event, agent based, or the system dynamic, right? So these all kind of simulation you can perform here. And one of the beauty of this package, you can say it is a GIS based. So you will be also get multiple features, and where the you can say where in terms of dashboard you will be customized whenever the clients or your customer has required. Okay, so let me before start. So we have for to develop this model we required the three kind of the agent. So first agent is the drone, right? Where we have these are the logic basically, and where we have put here, right? So drone has with the truck depot is started, and then it will be moved to the uh, locations, then deliver, and then moving to the truck, and then wait for the truck. So right, because we have yesterday we have discussed about the synchronizations. Once we talk about the truck drone, then synchronization is one of the biggest challenge for considering there if you develop the model of the truck drone, right? So this wait for the truck, either truck is wait or sometimes drone is wait. So how you synchronize this both time of the waiting time is there. The second agent is the locations where, yeah. So these are the locations if you talk about where we require the longitude, latitudes, and what are the address of that particular and how we location we have index. In terms of maybe sometime it happened the similar customer has order in the same location. So we have to make it in the proper indexing here, right? And these are the variable we have defined in terms of delivery completed or not, or delivery completed by the drones, right? So that variable we have designed here. Then we go to the third kind of agent where it's yeah, location truck. Yes. So this is a truck agent, right? If you look in the corner of this is a truck we have designed in the 3D where you have seen, right? So this is a truck where we have again, I mean, home locations we have given where the depot you have started. It start from the depot and it move to the again locations where we have assigned. Then it will to deliver and then it will be finally wait for the destination, right? And where the message alert will come and then again drone will become and then both will going together. If talk about in terms of variables where we define the from which location we are going and from to what location we are going to send, and is it drone or it is a truck, right? So that will be also decided. So these are the kind of variable we have defined here to develop the model. Regarding the data, if you are feeding these all data we have, if you go with the very details of that, let's say the experimental, what time we will start, what kind of unit. So this, I'm not going to cover that portion. If we go with that, it's very elaborative in terms of all data. So I will talking about the customers and talking about the different, locations, right? And so let me run this model. Yeah. So before running the model, we have also built the model. We will check either this model is perfectly built or not. So build up, we have checked. Let me go to run. Yeah. So this is a proper, you can say the dashboard, and behind the dashboard there are multiple logistics. I mean the logic where we have set up, and then we have said already we have discussed. So we are basically looking how many customers are there and how many customers where we are delivering by the drone or by delivering by the truck, right? So we'll start this model. So if all 50 customer, if you're talking about, these are the 50 customers, right? So these are the cluster of customers. So model has started. I will just make it more speed up so that yeah, I think this is the first. So if you look here, this both process has started, and these all blue color icons are basically talking about the number of customer which is unserved, and those customer has served that will become as a green color. And these are the depot, or you can say the distribution center or facility center particularly, where they will serve the all 50 kind of customer here. Okay. Going back to the module where in the backend how exactly it works. So this is the delivery model where if you look how this all assigned module has worked accordingly, and that will be checked with each places, right? So we have to back again the model, and let me back again. Yeah. So we'll back again and we'll see what are the different customer have served. So if you look the customer which is served by the green colors icon, where it will be served by the drone, and some of the customers which has served by the truck which is with the pink color, right? Similarly, if you look here, the truck module, where again this all logic has worked. So either truck moving for to particular location, then it go to deliver, then it wait for the destination. So in this decision, either they will wait by the drone or truck, right? Yeah. Let me speed much more. So these are the different location where customer has served. Okay. So we have considered only, let me zoom a little bit so that you will be. So if you look here, this truck has particularly assigned by the particular route, right? So whatever the road infrastructure has, accordingly it's going to serve. So customer number 25 has served by the drone, right? So that's why it is the green color. Okay. So almost 50% of customer has served. So these all customer has served, and these are the basic model we have developed, and we are also going much, kind of the adding the more constant, like, in terms of capacity, in terms of drone delivery capacity, as we discussed yesterday, like lot of things we have to cover in terms of once you make a complex model, right? So this is a simple model to demonstrate how this truck drone delivery will work. So hope you all have get the idea about this truck drone delivery system. Any questions so far? Hello. Yeah, one question has popped up. Let me see. Sir, is the right truck driven by the two persons and drone operated by the one person? Yeah, so this is again, if you talk about the operation level, definitely we required the two-person where one will be the as a driver, you can say, and the another one required for the operation of the drone, right? So again, it's like a semi-automated. It's not the completely automated where the drone will come and automatically they will pick up the, from the particular truck, right? So in this case, the one operator is required for drone and another operator will required for the as a truck driver, right? Any other questions? So please, raise your hand if you have like some questions. It is icon is there where we will check out usually, and we'll also, and if you want to some your opinion, please let us know so that I will also make a more interactive in terms of your suggestion or your comment here. So those who are really interested, please click on the raise hand bar where we will open the floor for discussion as well. Okay, I think no questions. Okay, fine. So let me move to the another case. Yeah. So another case is
Shankar Raman has asked one
Uh,
question.
There is a question. Yes.
yes, please. Yes, Raman has a question. Let me go through it.
Sir, should I read out the question?
No, sir, it's fine, ma'am. I think I will be able to see here. Sir, this is applicable only for one product delivery, and let's say the examples of clothing company with the delivery of the customers shirts and the pants for the different customers will be the so currently I'm using a single product, right? And single product, single drone and a single truck, right? Of course, where in terms of product you can add the multiple product as well, but in this model we'll simplify format we have considered as a single product, right? You can take the different kind of product as well, like a grocery items, or like you have given the examples. Raman has given the examples of as well, like a shirts, right? So you can take it as well. It depends upon the requirement of the customer where you can add the different product, right? Hope it is fine. Okay. Oh, great. Another questions also pop up. Yeah, thanks. So now this is a if you look this truck drone delivery. Now we will moving towards the drone delivery model. And so once we talk about the drone delivery model, then it's of course this is the faster than the traditional delivery method of the vehicles and the truck, but not limited by the established infrastructure. That is another constraint you can say where it will be required, and it faces a less obstacles as in terms of the traffic congestion and other things, right? So that will be also another opportunity, you can say, the advantage of this particular delivery model, and it significantly reduce the cost and time, right? So in terms of if you go with the very large scale of that, then it will be reduced because where the manpower requirement and other things, but only deployment in terms of a lot of if you look here the procedure and the requirement are there, that will be the challenge for the company where deploying this drone delivery. So again, further go deeper about the, I'm not going with the engineering sides where the design of the drones and all those kinds we are considering here. We are simply talking about the different kind of drone based on the how much capacity of the payload capacity they have, right? Into the- Yeah. So these are the different category of the drones where it based on the payload capacity of the drone, we classified it. And then if you talk about the requirement, then again, GPS system is required, anti-collision lights, so right. So these are the, and then we have also talking about the flight controller with the flight data. Then what permissible height of you are going to fly, either it is a nano kind of the drones or it is a micro kind of drones, right? Then another one of the government concern is there. I mean, most what the government side, if you look, so these are the permissions and required where we have, I think we discussed yesterday as well. Okay. So air defense clearance you have required, then you have required the approval of the Directorate General of the Civil Aviation, no fly zone. So some of the locations where the government has already defined there is the dense populated area, right? So that will be another constraint is there. Okay, so let me dive into the how this process will work basically, if we talk about the only drone, so it is a very typical examples where you can look end to end order fulfillment, workflow for the drone delivery, and it will be give you the very clear idea about how exactly this operation will work once we consider only the drone delivery, right? Not I am talking about the truck drone delivery where we study we have discussed. So if we only talk, so we have got this report from the Wipro had done very good work on the this particular, how the drone will be deliver the product, and this is the examples of the e-commerce industry, right? So this is considering the product as a e-commerce, right? So if you broadly look, this process are classifying to the three zone, right? So first zone is talking about the customer. If you look here, the left hand side of the bottom, right, where it's talking about the customer, and the second one is talking about the warehouses, hub centers, and the drone launch pad. So these are the middle center on the top, you can say, where this is the second zone is talking about, and third zone is the merchandise and vendors, where the your pickup will be happen from this particular facility, right? So these are the three broad zone. If you go on the top of the right hand side, where some of the dots, if you look here near the warehouse, you will get the pickup points. Uh, Similarly, if you get the merchandise outlets, where you will be get the another pickup points, and this is the yellow dot where you will be get the drop point. So these are the dedicated slots, or you can say the dedicated locations where this drone has located here. Of course, this will be vary with respect to the location to location, but in the diagram you can see here that point they will consider to deliver the order of the particular customer. Okay. Then there are two kind of the dotted diagram. I mean dotted line are used. One dotted line, this is a light one we are using for the delivery from the warehouses. Another dotted line, the dark line is if you have delivered from the merchant, right? So let me start how basically things have worked. So let's say the customer has ordered the some uh, items, and these items I ordered through the app, or maybe the the third party where have a dedicated web page, or there we have maintaining here, and that this order information of the customer order, it went to the e-commerce company where they have order, right? So then it will be, so again if you look here, this order will went to the there are two way of, so first it will went to the remote pilot center where they will confirm the order has received, and they are start ready for the pilot from the pilot center for the drone, right? Then another piece of the information are went to the warehouses where it will be checking either this order are available or not. If order is not available, then it same information is sent to the again to the merchant, right? So this depends. So this order should be delivered from either the warehouses or from the merchandise outlets, right? So these are the two way where the order can be delivered in terms of where these pickup points have mentioned here, right? Then in parallelly, there are warehouses has also concerned with the drone launch pad, right? So these are dedicated launch pad is there where they will come and the item will be put there, and then it will be fly for the customer. So if you look here, this dotted line. So if the customer order has delivered from the warehouse, then it will be come under this light dotted line. And if the customer order has delivered from the merchandise outlets, then it will be the dark dotted line, right? So this is the basic and fundamental way where like a ground staff team and there are multiple stakeholder will required where site manager we have required for the managing the drone launch pad. Similarly, and then finally, we will also look about the return. Some of the items, if you have assigned for the reverse logistic, where from the customer to the either it's sent to the merchandise outlets or it's sent to the warehouse. So this return facility is also there. If some item are defect or some item are not satisfactory for the customer, so they can return as well. So that if you talk about the again forward loop as well as the reverse loop, both have considered in this model. Any questions so far to understand this? I think it's very clear about from the pictures. Okay, no questions. So let me dive into the second case where this is a very interesting case of the, this is for USA case. I mean, this is a Baltimore is the one of the locations of the where Amazon fulfillment center are there. So what are the things are, if you consider about the location data, and there are multiple things we'll discuss in details how this are collected. So this is a particular location where if you look here in the star, which is the fulfillment center, it's the Amazon fulfillment center. Basically, they have trying to take one trial of in this particular location. Then what kind of service area? If you look this shaded circle, which is basically talking about the 7 nautical miles radius of the service area of, if the customer is coming within particular region, then drone will be able to deliver the product, right? Then we'll talk about the this is the, it's kind of facility, the fulfillment center, and what kind of drone they have deployed. This is a MK27. So this is one of the classification for the drone. Okay. What are the basic problems? So they, in terms of problem statement we are talking, so they wanted to determine the minimum number of the drone required to achieve the 95% of the service level, right, in terms of on-time delivery, and for the 30 minutes of the delivery time window. So if you look, these all three kind of expected output they will assume in terms of this. This will be how many numbers of drone we have required, and they have also maintained the 95% of the service level, right, so that they can achieve. So how many drones we have required, that will taking care of the model. And the time window, it's very specific. They have given 30 minutes of time. If within the 30 minutes of delivery time, if it is not delivered, then it is, that service level, I mean, you can say this is late delivery. Okay, so now we will coming about the data, where this data has collected. So this is the data basically collected from the population of US Census Bureau, where they have collected the data. Delivery location based on the census data and longitudinal, latitudinal, they have tracked it. And then daily operations, it's also generated by the some kind of weighted they have given as a probability distribution, right? And then based on then the population of the exploited from the national average, the what kind of population of that particular geographical location has, so where they have considered the order. So this case are basically discussed from, I have took from the MIT study. So this is one of the study where they have developed. So before moving to this particular model, let me start with the what are the basic fundamental concept of this drone delivery system and how exactly it will work. So what kind of input data you have required, right? So input data you have required in terms of service area code and population density, delivery locations, order rate, how many frequency of the order you had, what kind of fleet size you are using. Fleet size in terms of, you can say the drone, kind of drone we are using. Then what are the delivery time window. So these are the data you have required in form of the input. Another form of the data which will be assumed in terms of, because again, this is the initial phase of study, right, where we are also looking about the pre-flight timing and battery swap times, drone speed. So these all data you also require into the model, and then these all data goes for the raw data outputs there. Some, and I mean, in terms of they wanted to make one dashboard. So this is a raw data output they will get, and then interpretation happen, and where we'll optimize the whole fleet, how much size we have required. Where if you look this red boxes, basically in terms of, these are the key variables. So it's order rate and fleet size is very, very important in terms of, if once we look in the model, right? So that is the key variable they have considered here, and then they will interpret it. And then this is again cyclic approach. What are the interpretation happen, where what if analysis they can do, they will tune up the drone speed, and they will tune up the swapping battery, and then correspondingly they will get the simulate the model. Okay. So what are the KPI? So again, this is the part of the, there are model, if you classify very broad level, then one of the order model, like if you remember the previous examples where we talk about the one of the agent of the truck we have considered, another agent we have considered the drone, and another agent we have considered location. So similarly, these are the model they have considered, order model, and this is the drone models. And these are the KPI they're trying to calculate. I will run the model, then you will get more clarity about this. KPIs. Okay. So let me dive to the model again. And before model, uh, so this is very, if you talk about the customer size, there are more than, around 12,000 customers they have served here, right? It's a huge amount of the customer and data they have simulated. So if we talk about around, it's 12,000 data point is there. Okay. And then these are the all longitude, latitude of this data. It's a huge amount of data they have simulated. This is order they have generated random, and then this is the particular location where they will track it, right? And then this is the latitude, longitude, and distance is, so again, these all distance within the 7.5 of, nautical meter, right? Where we have, if you look the model, they have also giving the constant about the nautical mile radius, right? NMR. So these all will be come within this particular range, then it will be work, right? And this is the population of this particular location. So that way they have generated and simulated the data. Let me run the model so that you will get more clarity. Okay. So again, here is the one model is the customers, another model is a drone, and third model is the fulfillment center. So within customer, if you talk about, so these are the logic they are putting here, right? What are the ID, then tracking, and then what is the longitudinal, latitudinal locations of that particular customers. Either this, so we will also consider the variable, either this order on time or a number of order late. So that will also we will calculate. So that will calculate the service level as well. And these are the basic logic of that, where they will late or delivery wait, waiting time in terms of. Then the second module is talking about the drone. It's a simple in terms of what are the client are there and how much target done in terms of payload capacity and what is the current drone speed you have. And with latitude they have flying. So that all things they have considered here. In terms of fulfillment center, so this is the logic they will created here. In terms of fulfillment center, how many orders are coming, so order coming enter here, and then it's will be tracking is started in terms of delivery time started. You can say it's a lead time where it will be started, and then it will be siege. If order are there, then it will be then release, and then I know. So this delivery time start and the stop are basically talking about the lead time of the particular, and then finally it will deliver to the customer. So this is particularly model will define for the order. Similarly, we'll define for the drone, where drone resource task started and it will prepare the time to the load access. Then it go with the different model whenever the logic has required accordingly, and it will be again seal the order if order is there, and then again release, access, and return to the fulfillment center. Because drone has again back to the return, so they have also keeping the in the model they will back to the fulfillment center, and then it will be drone has returned on that particular, right? And these are the KPI they have considered in terms of service level and how many orders on time, what are the average delivery time of the particular product. Okay, so let me run this model so that we'll get more clear idea about. So before that, we will build the models and we'll check either it is a fine, so it looks fine. Now we will run this model. Yeah, so these are the speeds there. I will reduce the speed so you can see here, how this movement of drone is happen, right? And correspondingly, these are the parameters. So if you talk about the customers, how many customer are there, right? This is a fulfillment center. This is a drone. How many drones they have required? So currently they are using 100. I mean, it's exactly if we talk about 1054 drone they have used, right? Then you look how many orders are delayed because they have given the time window of the 30 minutes, right? This is a delivery time. On an average, delivery time is around 20 minutes. This is a frequency of order. It's maybe sometime it's the peak order came, right? So if you look here, these are the peak order time where order is more in that particular point. And then final, talk about the on-time delivery, and this is the delay. So, how many, which kind of order has become the delay. And finally, it will be come up with the what are the objective and target they will set up. So this will be come up with the 96% of the service level, and they have so out of they have 595 orders has delay. Around 4% of order become the delay. Okay. So these are the kind of this is the second model if you're considering about the drone delivery. Any questions so far?
Sir, where you are finding this data and what is the format for that one to input in any logistic?
So format we required in the Excel, it's simple Excel data and data, as we mentioned, it I have captured from the one of the study of the MIT, one of the research group has working on that, and it is a public access data. It where I got it from there. So based on that, I understand the model.
Sir, if you can share that site or something so that we can also practice. Like I'm practicing analogics, but my problem is that I'm not getting the data enough for that, sir.
So for any logic, if you go to the, there are multiple, I mean, there is no deal with the data point. I understand if you want to be real data, then definitely, this is also simulated data. I can share if those who are really interested. And in terms of those who really wanted to explore this software, you can go and there are multiple examples are there. And it's model, they have inbuilt model where you can practice small model, and based on that you can as a classroom, or maybe if you're those who are consultant, they can also they are very helpful to make in both sense in terms of your so if you talk about very broadly, this is the concept today. People are talking about low code, no code. So those who have no idea about the code as well, you can work on that, right? No mathematical model and all those things we have also required. Those who have a small background of the Python and Java, they can work on that particular software and packages.
Sir, I have one doubt, sir. Sorry to disturb you.
Yes, it's always welcome, sir. It's not
Sorry.
disturbing.
Sir, can we go in capital markets, sir? What all the coding system and machine learning, all those things and all? You have given that page, Can we go in capital markets, please? If I'm wrong, please correct me, sir.
Capital market means, sir?
That is about share market or something like that.
Yes, it will be, but my context is more related to the operation and supply chain. I can understand where you can run. It's your logic if you have wanted to like for the prediction of that particular share market data. So based on you can do that. I mean, it's also simulate the data, and you can look how this trend basically the cost of the particular a share will be how to increase decrease. So you can do that as well. It's a multiple application. This software is not limited to the only operation. So my application is more about the because context of the last mile delivery and supply chain. You can do that. You can explore where you can go and check. So let me show you those who are really interested. So you simply go to the AnyLogic's platform. So very nicely they have, I mean, even in terms of, there are two kind of version of the packages. One is talk about commercial package where the company are using, and one is the non-commercial and academic, you can say personal learning license. So this is the website where you can go. There are n number of model they have developed and deploy here. Let's say for understanding, you can also.
Sir, I feel simulation, those things that you can use it in the marketing data.
Yes, sir. It is a context for all domain we can use. It depends upon the logic how it will be created, right? Like there are three versions of the license. You can go with the, I would suggest person, there is no cost required. This is a free version. There's small model you can, develop by creating the logic. This is for the researcher where the institute are wanted to take some project or some consulting assignment, consultancy. So they are going with the university license. And if you go with the professional where industry are using, so there, I mean, it's a very high cost if you are going through the professional. So I would suggest for the classes, those who are really interested to make it more interactive in terms of, because the beauty of this software is the GI based software where you can visualize the, movement of the items, product and everything, right? And in terms of resources, these are the different resources. There are multiple books are there, videos and training materials. Sometimes the workshop is also conducted. Free of workshop is also going there. They are also making some academia documents like those who have papers and something there, so you can also go, your concept. So this is a very generic software, any logic where based on your logic, you can, make the problem in context of marketing or the finance or different domains. You can do that.
Sir, can I ask you one more question, please? Don't mistake me. I am Dr. Krishna Sudhir, sir. I am taking one subject for operations management for BBA graduates,
Yeah.
operations specialization. I am taking forecasting and inventory management. That subject is there for operations in BBA operations students, finally year.
Yes, yes.
Can we use any kind of, separate software for that to find out RP, RFID, something like that? No. Can you suggest me any best course or any certification course? But say time being 2 to 3 weeks, like NPTEL, how they are giving. Any other courses are left? Please help me, sir, in
So
that
the
regard.
forecasting, sir, you can go and search it like I have also taught in the supply chain analytics course, demand forecasting, right? I'm not going in the very theoretical level of that. So you will be get, I mean, very good kind of material from there. I will be share some of the, the books also where if you talk about the integrate with the AI, and if you wanted to be more deeper about that machine learning point of view, especially if I'm talking about a demand forecasting. I'm not talking about a traditional forecasting approaches and different kind of the errors and different kind of the techniques, time series forecasting. So I'm going more about the where if you talk about the demand forecasting in supply chain, where have if you talk about in context of the any logic, I'm not sure that module is there or not. So maybe you can go to the resources. One of the help module is there. You can go in the website where you can search whatever the help you have required. So let's say your topic is forecasting. You can go and search here as well.
You have got lot of patience, sir, when you are giving your question and answers and all. I have seen you. I don't know your age, everything and all, but you are giving very good, patiently you have given answers for all the things. Good, good, good. Program is very good. Really appreciate all organizers for bringing you like, Ramesh Kumar, Mr. Ramesh Kumar. Thank you, sir. Very much. You have given a nice presentation. Thank you.
Thank you so much.
Thank
So,
you,
sir,
sir.
you can, everything we can't cover in this span of time, right?
Understood, understood. See,
So you
conducting this
can
kind
go
of
through this
program
module.
online
I will be
is a
share
very
this
difficulty,
link with
sir.
you in the chat so that everyone get the idea. And those who are really wanted to be further help, you are most welcome. Just ping me through the mail or send me the where whatever the support we require. We are happy to help you.
So I request all organizers, can you share these kind of details? It will be helpful to recollect, and if possible, if your mail ID, so that we can have a kind of discussion to rectify our doubts or something. If they feel burdened, no. If they're happy, then they can share all the details of yours, so that in future we can get in touch. Because the knowledge hub like this. But I'm very happy today. For the past 2 days, I'm seeing that all the sessions and all. But today is having a good meal, sir, for me. I'm very much thankful to you for giving very good inputs to me.
Thank you, sir. Even for one
Thank you so
problem,
much, sir. If
we
Ramesh Kumar sir doesn't have any problem, no, we are happy to share his details. No
That's
problem,
what,
sir.
madam. That's what I'm telling you. He's having a lot of patience in giving answers. So you can bring him for another session also tomorrow, day after tomorrow, something like that. We feel very happy.
Yeah, thank you, sir. Can we proceed, ma'am?
Please, thank you, gentlemen. Sorry for the disturbance. Please, sorry. I'm discussing all personal, unwanted things. But anyway,
Sure, sir.
good program. Thank you.
Sure,
Thank
sir,
you.
you can.
So let me dive into the third case where it's again
Sir,
interesting.
Shankar Raman sir has asked a question. So the model that you have presented yields 96%, and what if we
Yes.
want to achieve? Yeah, that question.
Yes, so Sankar sir, basically we are here talking about sir model that you have presented in 96%, and what if we want to achieve from the model same more efficiency delivery where we want to modify the model. Yes, sir. It you can. It depends. Like there are two things you have to tune up. It's the time window and the how much efficiency you have required. So if you look, company are wanted to set the at least 95% delivery reach on the time, right? So that's why it go beyond 95, right? So that's why this 96 come into the, if you talk about the model where it will become, right? So company are worry about the trade-off between the how many, so you have to taking care of the number of delivery time window and number of the drones you have required, right? So that tune up you have required, and you can say the trade-off between both, how many drone you have deployed within this 30 minutes of the delivery time. So that you will be get it, and that will be data you can take the different what if analysis. Let's say I wanted to be 90% of delivery time. So how many drone we have required at that moment of time, right? So that could be feasible and possible. Yes, validation is always is a one of the constant. So one of the best way you can say there are two three way where we can validate the model. One is the what if analysis you can perform. Second one is the always have a Delphi technique, or the experts where they can help you to develop whatever the model you have developed, it is a right or wrong, right? Or maybe the industry expert will be help you if you have developed the model, because simulation is a black box where it's how the process that happen. It will be, especially if you're talking about Pradeep about the the research perspective, it is very difficult to again publish, right? So that will be always have a constant to validate the model. So these are sometimes also if like a sensitivity analysis we can perform, what if analysis will perform, expert opinion. So these are the three four method we have usually approach where, or you will be connect with the some very good practitioners, they have a good idea about this that, so you will be get it. So you will be focused about the input and what are the KPI you have, and then you can correspondingly you will be tune up the model as well. Okay. Okay, fine. Another questions? No. Okay, so these are the third case where we are going to talking about again drug drone delivery. So this is a case basically we have captured from the one of the good papers. A star paper is a TRE where they have solved this problem. Right. So this is the Knoxville. So one of the location is the USA. This is a state of Tennessee, right? So again, in this model, we have considered 100 customers and order fulfill. It's a one delivery center, you can say, or order fulfillment center. They are there, and the service time window they have considered here only 8 to 10 p.m. Right, 8 a.m. to 10 p.m. And so this, and what are the service area again? So if you look here, the previous question are using by the radius, they are using by the particular LYL, you can say, in term particular service area they have calculated, right? And they're trying to minimize the total delivery time by deploying the truck drone delivery. If you are going with the traditional approach of the truck, then it takes definitely more time. So they will make a hybrid approach of truck drone delivery where they will minimize the delivery time. Okay, so data again, it will be collected from the US census and the delivery location from the Google API they have using, and order delivery generated artificially. So these all are the artificial, I mean, you can say based on the probability and the population density, what the previous examples have did. Similar way they have did it. Okay. So this is the typical you can say that travel time required for on the road, right, network. So these are the variation are there with respect to the different time. Okay, and usually the peak hour time is 8:30 and the another 7:30. If you look here, the so in terms of look here, this in this particular time zone they have again pointer. So these are the peak order where more, at this moment of time, more order will become. Let me run this model again. And this is also any logic cloud. So those who are really interested, you can go in the cloud. You will get n number of model is there, and you can in the class or maybe for the purpose of your research, you can do here. So these are the models which is very similar to the model we have developed in the Pune case. If you look right, so they are using one DC is there, and these are different customers, right? So that way they have developed this model. Okay, so I think this have run. So based on that, these are the KPI they will consider, and so this is also one of the the model in terms of drug drone delivery and where what are the output they will expecting. So they will come up with the KPI. You will say the average delivery time of the 346.9 minutes particularly, and to deliver the 100 customers, right? So this is the on an average time they will calculate it, and how many trucks the deliver by the trucks. There are 44 packages out of 100 they will deliver by the truck, and the 56, so more than 50% of the load has delivered by the drone as well, right? And the dynamic policy is save up to the 28.6% of the delivery time. So where company are, they are giving more customer, I mean, they are trying to reduce this lead time by using this truck drone delivery hybrid mode compared to the deterministic mode. So that is the sum output. If you very quickly summary, you can look. So these are the three KPI they will expecting into the Knockwell delivery model. Now we will move to the very interesting one, another case. We are using the different packages, not the any logic we are using the any logistics. So this is a sister company, you can say, of the any logic. So this is again the case of the food delivery. In terms of we have take the Bangalore locations. So if you look this case has unique from the previous three cases what we have developed and what we have discussed basically. Yes, some pop-up is coming. Yes, please. Someone has raised your hand. Yeah, please let me know, sir. Or maybe you can speak. Some hands I have seen. Okay, maybe we'll discuss once we have covered this. I would suggest please chat here so that it will be better for me. Okay. So I'm using the two. This is different from the other last three cases we have discussed. This is for the so it's more about the delivery happen. If we those who are from the Bangalore and the other places, you can see also this is very unique way of delivery of the product by the quick commerce are using in Bangalore, right? This is a I think the company name is YOLO. right? So this is the e-bike delivery where they are doing, and another one we are using here is the general, I mean the motor scooty. So these are the two delivery basically used for the q-commerce. I'm considering that kind of cases. I will use here that model. So I consider for this problem, there are one DC, or you can say the dark store in the particular location, and there are 20 customers they have serving. Okay. So that is the basic location. You can say these are different location of the customers. Some of from the Manta Tech parts, some of the different location of the. I mean, you can say the Bangalore. So before moving to the this all, let me go with the data. What kind of data you require for this particular model? So these are the locations I have considered, right? So the first one is the central kitchen. You can say this is a problem of the food. It's not the exactly the grocery item where we can say the dark store. So this is a central kitchen. IDC central kitchen is located, and these are the longitude and latitude of the locations, and these are different customers they have doing. Okay, we will go with the how many orders they have doing. Will details we will discuss as well. Let me open the model. Okay. So these are the particular central kitchen, and correspondingly these are the different customers, right? So if you look here, if you click on the icon of this, all blue color icon are showing the different customers where we wanted to deliver, and these are the particular route, right? Where the and the possibility where the rider will go and deliver the particular product, right? So before going to the model, let me, so there is one of the, so these are any logic software where you can, look all kind of the model and you can solve it. So I will go with the data, what kind of data we have feed in the model, right? So first we will talk about the 20 customers where we have already discussed, right? Then what demand are required. If all 20 customers I am using currently the one product. So there are 20 customers has a 20, demand, but maybe they have ordered maybe more than one food items, right? So that's why we are considering a three quantity, right? Okay, so these are the quantities, how much demand have required of different customer, right? So these are all different customer HSR, Prestige. So these are the different customers in terms of the location. So only one central hub as a DC you can say here in the D. So in this one, DC is either used by the central hub or maybe sometime it will be used as a factory as well. It depends what of context of your problem you have. Then I am using the two kind of fleets as you've seen in the initial first pictures of the first slides of this case. There are two kind of the mode of delivery we are using, motor scooty and the urban e-bike, right? Now we'll go what. So right now we will assuming so this central kitchen has a infinite capacity, right? I'm not because this is a simple model we're trying to develop, right? So this is the inventory has infinite capacity of time. And what is the loading unloading, items? So these are the loading unloading kind of data we have required. Okay, which vehicles you have selected, right? So we have selected both kind of vehicles. We have not restricted this particular location which vehicle will be delivered. This model will decide which customer has served by either the e-bike or the motor scooter, right? This is the locations. So one central warehouses in terms of central kitchen and remaining 20 customer points. So these are the data points, 11 customer are there. These are the path. So path we will make in terms of group. So we'll make a cluster of all customer in the one group. So that's why all location to all locations. But and then distances are also there are multiple rules are there in which basis you wanted to calculate this. There are policies are there. I mean cost calculation. So I have calculated based on the distance based cost per stop, right? Someone is also calculate distance, I mean fixed cost, maybe the one trip you have considered, then how much cost is required. Someone is the fixed delivery cost if you have a third party where, so there are multiple scenarios there based on someone is done by the how many product and distance both you have considered, right? So that way you can also look here. These are the cost, variable cost. So we will talking about the cost per stop, right? Then one another beauty of this software you can also say where you will be also capture the carbon emission, how many CO2 emission will happen. So those who are concerned about sustainability context, you can also add the some factors. So let's say this particular stop happen, then how much distances if you move, how much carbon emission will happen. So that will be also you can capture in the terms of cost, carbon cost emission, right? And separate is also CO2 calculation you can also do. So, but this problem I am not looking that particular aspect of this carbon emission as well. So those who are interested in sustainability context in operations, you can go ahead with the CO2 emission as well. This is a very short period. We'll only consider the time of 2 days of spend. Actually, it is a 1 day. I will show you in the model how this time we will fix once we run the model before model will show. So right now it's showing the 1st January to 3rd January we have taking the time. Product, only one product. It's a quick meal box we have considered. Shipping terms of there are two kind of the order we have delivered, right? So there are again multiple rules are there. Either it is a full truckload, less than truckload. What kind of priority you are given? This is a first come first in, first come first go. There are multiple, these all priority are there, right? LTL is expected lead time. So that all kind of priority you have given. What time you model you wanted to start? You have a constant like morning 8 o'clock you have to start the order. So that kind of thing you can also incorporate into the package. Where these all sources are coming. So these are the data. This is a time window. Okay, so this time window, these are different customer location where orders are receiving, right? So this time they have started. So sometime 11 o'clock they started, 11 a.m. the orders came, right? So that is again time of receiving they have considered and ending time in terms of they have delivered that particular product. So basically, let's say some order is coming at 10. So they have giving the 2 hour of the window where they can deliver, right? So they will also consider that commitment time, you can say, of the particular delivery. These are the unit version where you can convert. Let's say this sometime it's not this particular problem is simple where the pieces of the orders you can say simply. Sometime if you are sending the item from X place to Y place, then you will be get the either in terms of quantity or sometime in terms of the volume, right? So that will be also you have to convert it. So let's say 100 ton of the capacity of the truck if you are sending, then you will be convert this particular unit as well. We are using two kinds of vehicles, right? What are the capacity of? So the e-bike have a capacity of the 4 because this is small size in terms of where we can't have a capacity of more than 4 packages they can deliver at a time. And this is a scooty, they have a more kind of they are the 8 packages they can deliver at a time. So that capacity they have given. We consider 20 kilometer of the per hour in the city. It's very difficult to go, by the lot of congestion and traffic all of this. So these are the average speed you have given. You can also use the different distribution. Let's say you wanted to make a very probabilistic way of defining this distance, this speed, you can do that, right? And so these are the vehicle type. So these are the all 15 basic model you can incorporate before developing the model, and this data you have to require it. Okay. So I will be run this model. So before running, you have to validate it, and there are different modules there. Like you also talking about the validations and comparisons. Like one of the questions is coming from where they will talking about how to validate this model, either it's wrong or right. So that one of the way you will be compare 2 3 data, and you can take the KPI at the end where you can validate. Somehow it will be help you in the validation as well. Okay. So I am moving to the running this particular model. Okay. So in the vehicle, this problem is related to the VRP again. You can vehicle that a milk run concept is coming here. Milk run is nothing. It's just like in the same vehicles has multiple order they have delivered and they will back to the again depot, right? So this is a typical optimization problem. That's why this iteration happen and then this solution has changed over a time, right? So now this will be come up with the solution. So their solution has suggested 8 milk run you have required, means 8 trip of the. So if you look here, these pictures as well, it's very nicely they explain, which vehicles if you are sending, which places. So this is the one loop or one trip you can say milk run has created. So there are 8 milk run you have required. So this is the first milk run where this different customer has served by the. Right, so they started from this particular location. First, we go to the Indira Nagar, then it served to the customer of the Bagme Tech Park, CV Raman Nagar, right? So that is the different way they will international tech part and then finally get to the Whitefield and it back to the again depot. So these are the similar loop has created where this is a concept of the milk run, right? So similar 8. So let me move to the what are the KPI we have calculating here. So what are the average travel time you have required? So they are saying 0.318 day we have required. What are the total transportation cost you are going to, right? So that way you can also look in terms of milk run shipment table where you will be get which customer has survived. So there are, if you remember, there are 8 loop are there, closed loop in terms of milk run, right? So first shipments, which customer they have covered and what kind of vehicles has served by them, right? So shipment one has covered the e-bike and that will be the this is a vehicle ID particularly, right? So there are 4 vehicle we are using for e-bike and what time they have started and what time it will be end. So these are the shipment table and shipment schedule table. Okay, so these are the current location, next location where it will be went. So every details you will be get by the particular shipment. So one shipment consists the multiple order as well. And finally, this is a number of order. Like there are 3 quantity in the first order, right, of the Manta Tech Park, and it will be sent to the this particular delivery happen at this particular time. You can also create the different modular. There are multiple things are there in this one, where we have again limitation of the class where we can't cover everything. Those who are really interested again for the academician and those who are practitioner, you can use these packages where you will be get a very decent amount of the uh, learning material in terms of your resources, right? You will be get here. Okay. One thing where yeah, so you will also get how many milk run you have required. Right now here they are showing. If you go to that table, you will be also get how many milk run you have required, right? So 8 shipments are basically talking about the number of milk run. So you can define your KPI. It's not restricted up to the here. It is up to your context of the problem, what you are wanted to define, and how this central hub will be serve this particular customer, right? So this is a simple problem of the food delivery. I think you all are on the time of the your food, and we end this problem with this food delivery problem, and we'll yeah. Any questions you have? Yeah, Pradeep ji have one questions. How could I justify my model is correct? Any benchmark model are available, and should I get that? I mean, it's again, I'm talking about the simulation in the black box. You know, it's a odd logic they have developed by the company on the back end, right? So for publication perspective, again, one of the biggest constraint if you are solving good practical problem, but they will asking how to validate the model. So there you can validate by the taking care of different, approaches like we have mentioned, like you can discuss like sensitivity analysis you can perform, what if analysis you can perform, where you will be get it. Okay, these are more about the feedback form. So this is the final, the case for the today's session particularly. These are some references where we have looking about the track down delivery problem, and those who are really interested for further, if you wanted to some in terms of resources you want or further you wanted to work on this particular package, you always mail me in the, this is my personal Gmail ID where you can mail me. So thank you everyone. Hope it is a session have some insightful for you. I'm not waste your time in terms of, I understand this is a very precious time for you with your family, but I'm trying my best to make it more interactive. Not I'm going more kind of the theoretical way. Yeah. Any questions you have or any suggestions where we can do that? Still have a couple of minutes. So if any questions you have, we can respond you. Thank you, Satendra, for your kind appreciation.
Actually, you were clearing as and when the doubts were coming. So I think now all are
Yes, madam.
with the question. No, I think as and when the doubts were coming, you cleared it. So I
Yeah.
think that's why now very few questions are coming.
Yes, yes.
But it was very great session, sir. I am getting the feedbacks in WhatsApp group and all. So
Yeah.
nice. So it was very good.
Thank you, ma'am. Okay, so thank you everyone. Enjoy your meal. We'll close the class with the meal problems. It's your lunch, I mean the dinner time, right? Okay, thank you.
Thank you, sir.
Thank you so much, sir.
Thank you, sir. Thank you. It was a very practical session, and we got many feedback from our college also.
Yeah.
Because many other teachers from different streams, they also found it very interesting because you were explaining with practical examples.
Yeah, so actually we thinking about not take up the much kind of the theory. You will be get it. I am trying to make it more interactive in terms of some practical way, right? So that is the initially we thought in that way, and it went well. I think based on your suggestion. And if you have any comment, then please let us know so that we can also incorporate in coming session.
Mita Naga has raised hand. We can unmute and talk. Sumita, if you want to talk.
Yeah, those who really wanted to, yeah, please.
I think she has posted a comment. Session is very real-time example oriented session. That is what she posted.
Okay, thank you, everyone. Thank you so much. I think we are on the time. Thank you, ma'am. Yeah.
Once again, thank you, sir, for your time and
Yeah.
contribution.
Thank you. Thank you so much.
It was so insightful.
Thank you.
Thank you. Participants, please note the feedback form is shared in the message box. So please do fill up the feedback form for session 3 that was completed right now. Our next session will begin in a couple of minutes. Dr. Maithili have raised her hand. Do you have anything to share with us? Please, you can unmute and talk. Okay, thank you. So let's move to the next session. Next, we have with us Mr. George Joseph Khalil, Assistant Professor of Marketing at SCMS Cochin School of Business, a professional with over 13 years of rich industry experience spanning retail and education. He holds a degree in electronics and communication engineering and MBA in marketing from Amrita School of Business. His retail experience includes key roles at Spencer's and Hypercity, covering operations, buying, and merchandising and category management across major metros. A certified retail trainer, he has conducted 100 plus training sessions for frontline employees. He also served as a regional manager at Time, a managing network of 65 centers. At SCMS, he serves as the placement training coordinator and nodal officer of IDEC, nurturing innovation, entrepreneurship, and strong academic industry collaboration. His presence today will bring a strong industry-driven application-oriented session. Over to you, sir.
Thank you, Elva ma'am, for the kind words. Thank you, SCMS. Thank you, AICTE. I hope I'm audible.
Yes, sir.
Thank you, AICTE. Thank you, ATAL. and thank you, participants. I know it's late. It's all time for dinner, but I'll try to make it as simple and precise as possible. So just a few disclaimers before I start the session. So like ma'am introduced, I am from the marketing domain, and I will be talking about the sales and distribution angle in route optimization, unlike the topic per se, the topic for the FDP per se, which is into smart manufacturing. And I would be talking about my experience having worked in the retail sector. So it would be more of a uh, experience sharing presentation, making it as simple as possible, because I understand there's a wide uh, range of audience from across disciplines. So to cater to everyone's understanding, I'll try to make it as simple as possible. And disclaimer number two is, of course, there is no tool-based demo or simulation per se. But towards the end, I intend to show you a video, a demo video of uh, an API being used for route optimization. Hopefully, that would be simple enough for you to understand. So I plan to do that at the end. But to begin with, I'll just start with some basic concepts, and I'll start sharing my screen right away. I hope my screen is visible.
Yes, sir.
Okay. So thank you once again for the opportunity. And so this is the topic for this session. Route optimization with sales and distribution goals. So that is where I come from. The agenda is pretty straightforward and simple. So what was it before there was automation or route optimization, and what is it like after route optimization, particularly from a sales and distribution angle? Why route optimization? Why do we need route optimization? And some real world examples. I also intend to delve on certain indirect factors which may not be visible directly. I mean, which may probably have got hidden from sight so far. Some indirect factors which affect route optimization. I would also try to bring in the linkage of ITR. I would explain what is ITR later on in the session, and its relationship with route optimization. And finally, to end, since we are all talking about AI and automation, there is a separate part on the AI bit in route optimization. So that is how I plan to take this session forward. Before I start, probably I can use the chat box. Maya ma'am?
Yeah. Sir?
Can I post in the chat? I just have a question,
Sure.
which I just
Yeah,
want.
yeah, sure. Yes, sir, you can.
So,
And your it's the PPT is not in presentation mode.
yeah, so I have just put one question. I would just like answers to this.
So the question is not visible for me. What about others?
1 second.
Okay.
No, sorry. Just give me a minute.
Yeah, sure, sir.
Okay, I've just put a question in the chat box. You could answer with whatever comes to your mind. So when a company is planning delivery routes, what do you think matters most today? You can answer from the point of view of a consumer. You can answer from the point of view of a company. What do you think matters most when planning delivery routes? Time and cost. Okay. Cost, delivery, and time. Minimize cost. So predictably, I'm getting a lot of cost answers. Route optimization, of course, we are discussing that. Efficient and cost cutting. Yeah, so more or less, I think the answers are all aligned to the fact that while planning deliveries, cost, time, efficiency, these are the major factors which uh, should be considered. Okay, so I'll now go back to my presentation and now before I start, I would like to acknowledge a few people who I have actually consulted with. Now these are kind of who's who of industry and got some inputs from them. So notably you have people from logistics, you have people from e-commerce, from Salesforce automation and from consumer electronics. So these are the people who I have actually discussed with and got some inputs from before I actually, went into this presentation today. So and really valuable inputs at that. And these have been incorporated in the presentation at some point in time or the other. So I would just like to acknowledge their contribution. Now, to begin with, I would like to play a very small video. It's a very simple video. But just to give you a very visual depiction of what exactly we are talking about when we talk about route planning or route optimization. So in this particular example, it talks about uh, different modes of transportation, of course, but it talks about primarily mail getting delivered to different houses and how it arrives at a hub and then it gets delivered. Now, if you just replace this whole thing with a warehouse and a store model, so just imagine if there is a central supply which is coming to the warehouse, and from that warehouse, all these individual houses actually represent individual outlets or stores. It would be a similar kind of a scenario. So again, you need to map out the fastest time to visit all the stores, and you need to map out the optimal delivery route. So this is something what we are actually talking about in this session and what we are dealing with. So the key point here is now we saw that there are several stores to be covered. Now every missed delivery window, missed delivery window, supposing you miss out on a store, you're not able to deliver for some reason, or every wasted mile, or you go the extra distance to deliver the same product, an unplanned issue or detour comes with a cost, and that is exactly what you were. That is exactly what you meant when you answered to my question. So, what is the most important factor? The cost. Cost is an important factor. Sometimes it is revenue also. So, uh, revenue is also at stake, and eventually there is customer loyalty also. So this is one key idea which I would like all of you to take or remember through this presentation. And the scope for this presentation again is restricted to certain sectors. So whatever example we discuss would be primarily from FMCG or the retail space, modern retail space, e-commerce, quick commerce, instant food delivery, and consumer goods. So this would be the limitation of our discussion today in this session. So all the examples that we talk about would be from any of these. It could be from any of these sectors. Now, coming to before and after automation. Okay, so to put it very simplistically, so before automation, what was happening? Route planning was manual. Before all these softwares and all the systems came into play, route planning. So when I say route planning here, I mean the sales and distribution planning was manual. It was paper and pencil. It was intuition driven. It was actually, uh, it came from the mind of certain individuals. It was physical map based, not like the virtual maps that we have nowadays. And it relied on beat sheets, local knowledge, and simple rules rather than on more sophisticated models or real-time data. So that is obviously, when we look back now, it is a big drawback as to how automation or route optimization was actually planned. Even now, if as we speak, when I spoke to a few industry experts, even now there are industries which actually do not automate. They actually do this route planning manually, pencil and paper. You would not believe it or not, but there are industries, there are sectors which still rely on paper and pencil mode to do their uh, daily route planning and delivery schedules. So, which came as a surprise to me. But given the nature of the product, which I will come to later in this presentation, it actually makes sense for them not to actually invest in automation, but rather go with a paper and pencil mode of operation. So if I have to now just compare before automation and after automation, or before the software came in and after the software came in, so you can actually compare it on various dimensions. So one is planning method. So the manual method or before automation actually relied on manual beat sheets, paper maps, intuition. Beat is nothing but the route which a salesman takes on a day-to-day basis. So every day he will have a different beat or a different route which he will cover, and in that beat he will cover X number of retail outlets. Whereas cut to today, you have GPS-enabled AI optimized tech-driven planning methods. Basis for decisions, local knowledge, past experience. So again, this is purely based on the individual's skill or competence, rather than relying on any kind of data-driven logic. So here today, when we have software, we have automation, we have real-time data, we can actually include constraints into the optimization, and we can also use predictive models to actually get the optimal delivery route. Route structure, if you look at before automation came in, was fixed cycles. You had a daily route, or this day of the week you will cover this store. Second day of the week you will cover another set of stores. and this was rarely updated. And this used to be like a ongoing process. But again, coming back to today, the fixed cycle has actually given way to dynamic routes, which are recalculated based on the given conditions at that point of time. Data availability limited, outdated versus real-time Salesforce. SFA is nothing but Salesforce automation data, GPS tracking, outlet insights. Efficiency, of course, there was more travel, fewer stores were covered. Today, most stores, optimal routes, reduced distance, higher coverage. So that is the big change which has happened. And of course, if you look at consistency, you are highly human dependent. You are dependent on the human capabilities before automation, and after that, not so much. So that is what automation and AI has actually done to these kind of jobs. Obviously, very difficult in the old.
So we can't hear you. We are facing a brief technical issue. Please bear with us.
Can you hear me? I'm sorry for that.
No problem, sir. We can hear you.
Okay, I don't know at what point it got cut. Okay, hopefully the screen is visible.
Yes, sir.
Okay, so now the question that we are asking is why route optimization? Again, let me clarify that this is in the context of sales and distribution. Why do we need route optimization given that we have discussed the advantages and disadvantages of before automation, before automation was there and after automation was implemented. So why route optimization? So I will again go back to a very age-old problem. A salesman starts from his office, visits each outlet once, and returns to the office. Now, there is an office and there are 3 stores. Okay, now this office can be replaced by a warehouse, and the salesman can be replaced by a truck which is actually delivering goods to store A, B, and C. So I've taken a very basic kind of a scenario, and the distances between each of these locations is actually given in kilometers. Okay, ma'am, is this available? Am I audible?
Yes, sir, you are.
Okay, fine. So now there are various solutions to this problem. So one solution is the exhaustive or the brute force solution, where you look at the total permutations of visiting 3 stores, and there are 6 possibilities, and an optimal route is found. So which is office, you go to store A, store B, you go to store C, and then you come back to office. The total distance covered is 13 kilometers. You have 4 legs. So leg being the distance from one point to the other, or that part of the route between 2 points is a leg. So there are 4 legs, and all 4 legs actually constitute about 13 kilometers in this particular scenario. Now there's a second solution, which is the nearest neighbor heuristic, wherein from the office, the salesman or the truck goes to the store which is closest, and then from there, it again goes to the closest unvisited store, and then the closest remaining store, and then back to office. Again, you get a distance of 13 kilometers. Now, this was pretty simple, right? This was a very simple way of looking at things. You can actually do it even mentally, if you ask me. Okay, so this is the classic traveling salesman problem, and whatever permutation you actually look up, you get the distance as 13 kilometers. Now, the new variations to the traveling salesman problem is the VRP with time windows, or the vehicle routing problem with time windows. That is an added constraint. Or a second variation is the capacity driven VRP. So where capacity is actually factored. So one is where time window is factored in. So the vehicle has to deliver at a particular point of time in the day. And the second is the capacitated VRP, where the vehicle has a particular capacity. So different vehicles have different capacities. If they're introduced into the system, how will it react? Okay, so those are the new variations of the traveling salesman problem. Now, if you see, the number of possible routes grows factorially with the number of stops. So what do you mean by factorially? It is basically the total number of permutations which are available with the number of outlets. For example, if there are 3 outlets, as in this case, the total number of routes possible to cover all the 3 outlets is 3 factorial, which is 6. Okay, so that is pretty simple to do. But what happens when the number of stores actually goes up? So we are actually discussing route optimization and why do we need route optimization? And this is the answer to that. So when your number of stores is 3, your number of possible routes is 6. Very easy to compute, either in the mind or by hand. But as you see on the left-hand side, your number of stores going up. So 3 to 5 to 7 to 10 to 15. So supposing you have a company which has got 15 outlets, let us say in a particular geography or a location, and that truck has to cover all the 15 outlets in a day. There are 1.3 trillion possible routes. 1.3 trillion. Computationally, this is actually beyond even computers, right? So the point I'm trying to make is, as the number of stops increases, the number of possible routes increases factorially. So making manual calculation impractical and requiring what we now need, or nowadays what we need as the algorithmic, software driven, or in latest terminology, AI based optimization. So this is the real need, or the reason why we need route optimization. It is humanly impossible to actually optimize so many routes. The moment the number of stores actually goes beyond a certain number. I hope this is making sense. Yeah, can I have a yes or a no? I hope this is making sense. Yes or no?
Yes, sir. It's a normal traveling salesman problem. No, not a big
Okay.
deal, sir.
It's not a big deal, but it's a normal traveling salesman problem. But the point I want to drive home is the number of possible uh, routes, which actually then uh, leads to uh, a problem with designing your route and optimizing your route. So now, what is the real world constraint which you add to these the traveling salesman problem? Just number of stores is one constraint. What are the other real world constraints? Now, the other real world constraints, especially from a sales and distribution point of view, is time window. So, what is time window? You need the vehicle to deliver at a particular time of the day, right? So, most probably it is a 1 hour gap or a 2 hour gap. There are priorities in terms of outlets. For example, every outlet need not be doing well in terms of revenue generation. So we classify in retail, we classify outlets based uh, on their sales, their actual sales, and their the actual profit that they make. So they are they are classified as ABC. So an A category store will probably be the highest priority. So what happens when the highest priority stores have to be actually uh, delivered to first? What happens when there is a sudden traffic problem? What happens that when you have a vehicle capacity issue? Uh, so all this actually makes manual planning even harder. So number of stores apart, the traveling salesman problem apart, you have real world routing constraints, which actually add to the complexity of the whole system. So if an outlet is now marked as priority by the company, that it has to be serviced first, routing must incorporate that constraint, even if it slightly increases the distance. So, which means there's a commercial trade off. So, which means you are going out of your designated route to service that store. So, which means you're actually incurring higher cost. But then the company comes back and says, no, it is okay with me. That store is giving me higher revenue. So, that higher cost is okay. So there is a commercial trade-off also uh, when you are actually servicing based on priority type of the store. Now, examples of constraints like I was talking earlier, time windows. So the the, the truck or the delivery must reach store 3, let us say between 10 a.m. and 11 a.m. Whereas the actual delivery for that store would probably be scheduled somewhere after 4 p.m. So then what do you do in these cases? So as per the optimal route, uh, there is a mismatch. Priority weight, like I was talking about, ABC outlets based on revenue performance. So visiting store 2 may be favored despite a longer distance, or visiting store 1 may be favored despite a longer distance. Commercial trade-off, financial trade-off. Third constraint, capacity of the vehicle. Suddenly you have a vehicle which has a lesser capacity than what you had actually planned for, or you have another scenario where you have multiple vehicles going on the same route. Fourth scenario, which is actually very common on in Indian conditions, which is the traffic. So these are uh, examples of constraints which are over and above the uh, the number of stores which we talked about in the beginning. Now, I just want to again give a video out here to highlight this problem visually, and then we'll carry on. Okay, so that is basically just a video format of what I just explained, and I hope the reasons for route optimization is actually quite clear by now. Now, when we talk of route optimization, of course, we are also, the topic actually talks about sales and distribution goals. So, for a company, what are the major sales and distribution goals? What they want to achieve with route optimization? So, one is outlet coverage. So, if you have a retailer, I can talk from a retailer's point of view. So, if there is a retailer, let us say he is having 40 stores in a particular city, and there is an FMCG uh, company who is supplying to the retailer. The FMCG guy wants to ensure that there is maximum outlet coverage on a particular given day, right? So, if possible, cover all 40 outlets in a single day for that particular retailer. And so, the next day, then he can probably use his fleet to probably cover another retailer. So, that is how the FMCG guy thinks. So outlet coverage is one sales and distribution goal. Fill rate. Now, what do you mean by fill rate? Now, fill rate, again, from a retailing perspective, is basically how much are you actually supplying against the order, right? So, major distribution goal over there. Fill rate is again indirectly linked to sales or revenue, because if you have good fill rates, you will have good stock availability. If you have good stock availability, you will have uh, uh, revenue. You will have stocks. You will have customers coming in, picking it up, and you will have a revenue of it. So fill rates again are a major sales and distribution goals. And because if you have optimum fill rates, or if you have near 100 fill rates, your stockouts also reduce. So when I say stockouts, your stockouts on the in your actual retail stores actually reduce, which is a major point of concern with a retailer and also with the supplier as well. The fourth point is salesman productivity. So if the salesman, let's say instead of a truck, the salesman is actually out to, you're actually paying him, and your objective, the company's objective, is to actually uh, ensure that he actually covers maximum outlets in a particular beat, in a particular day, in a particular beat. So that is objective number 4. And the final objective for any company, whether it is FMCG or retail, is customer service experience, right? So if you do all these, if you are able to do the first 4 points properly, then automatically the fifth point takes care of itself, which is the customer service experience. And ultimately, it leads to revenue generation and sales for both retailer as well as supplier. So, if I have to now talk about major sales and distribution goals, these are the 5. And these actually directly link or align with your route optimization, which is actually the topic for the day. Now, what is route optimization? Again, this probably would have been discussed in the previous sessions, but just to refresh memories, it is uh, finding the best possible route, the best optimal route or sequence of routes where vehicles travel uh, when they need to visit multiple locations. Okay, so this is a classic case scenario from a FMCG retail point of view. So retailer usually, if you are a big retailer, let us say like Reliance Retail, which has actually close to 18,000 stores in India. So it operates on a model where you have centralized warehouses in every state, sometimes more than one, multiple warehouses in a single state, and operating on a hub and spoke model. So you have the central warehouse, and that acts as a hub, and you have uh, X number of stores which actually serve as the spokes. So route optimization actually helps a company like, will surely help a company like Reliance Retail to actually optimize its logistics to different stores in different states. it would help a company, it will help a FMCG company like Levers, like Procter & Gamble. So all these major FMCG companies would benefit from this process of actually finding the most efficient route or sequence of routes. Now, what does it do? Actually, it minimizes 4 things: travel time. It minimizes the travel time. It minimizes the distance traveled. It minimizes the fuel consumption. It minimizes labor costs while meeting delivery or service time. So that is very important. So when I asked that question in the beginning of the session, I said, what is the single most important factor which you think would impact delivery schedules? And all of you all said cost. Most of you all said cost, time, efficiency. But along with cost, time, and efficiency, there is also something which is now equally important, which is meeting delivery or service timelines. And that is what now, if you see a trend, if there's a change in trend in companies, they are moving from a cost-centric model or cost savings model to a customer-centric model. Why are they doing that? Because they are seeing route optimization or automation or AI to be a revenue generator. It is no longer a cost reducer or something which actually reduces cost and reduces travel time. It's actually a tool which actually increases your revenue if you are able to deliver customer service by delivering the products on time. You're actually adding to the revenue of the firm. So that is how actually firms are looking at it, and that is a change which has happened in the way companies are actually viewing the whole process of route optimization and automation. Okay, so I think for want of time, I'll just quickly rush through these. Okay. So if you again compare so if you now have to compare before route optimization, there's something called route planning, which is a precursor to route optimization. And this table basically talks about the difference between route planning and route optimization. To put it in a very simplistic way, route planning is a one-time decision which is taken at the start of the operations, whereas route optimization is actually a continuous process. So I was talking to one of the experts just before this session, and he was saying that route optimization is actually done on a periodic basis, usually once in a quarter. And so that is what that actually aligns with what I'm trying to say. It is a continuous decision-making process. It is not a one-time thing which happens at the beginning of whenever you're planning to start an operation in a particular city or not. So that is just a very simple way of putting showing the difference between route planning and route optimization. Now, like I said earlier, evolution of routing has moved from a cost-centered approach to a customer-centered approach. So it is the focus is no longer on reducing cost, reducing time, but it is also on increasing revenue through a customer-centered approach, getting the products in a quick time. And that is exactly what we are seeing with these new age services like quick commerce, 10-minute delivery. So companies are getting more and more customer focused, and AI is actually enabling that. Automation and AI is actually enabling this customer centered focus. Static routing, which we were used to or which was being done earlier, has now moved to an adaptive AI led routing. Distance minimization focus earlier was on distance minimization. So if there were 10 stores, 20 stores, the idea was to how to plan the route so that the total distance traveled is actually minimized. But that is not the case now. So what has changed is from distance minimization, the focus has changed to commercial impact or revenue impact. So even if there is a slight increase in distance. That is not a problem. As long as there is a revenue impact, I think companies are okay with that. So that is a big change that has actually happened in this area. So like I said, traditional routing tools focus on minimizing distance, fuel usage, delivery capacity, but sales teams also now require these factors to be put into these optimization software, so which is off days or split shifts, priority outlets, what I was talking about earlier. So you have different outlets performing in different capacities in terms of sales, and then they're classified as ABC. So those should be actually factored into this software. Territory boundaries, availability of retailer on a particular day when the salesman is actually visiting, and visit frequency targets. So all these needs to be actually mapped to the software. So that is what is changing. So if I have to now put it pictorially, the old way was cost centric, the new way is sales aligned, revenue, outlet coverage, retailer satisfaction, compared to time reduction, distance reduction, and fuel reduction. So that is a clear change which has happened. Some pure efficiency to commercial outcomes. And when you're looking at commercial outcomes, when you're looking at commercial impact, the golden rule is, unlike in the past when the fastest route was the best route, now companies are looking at commercial outcomes. Fastest route need not be the best route. So that is the single point change which I was trying to highlight in the last few minutes. So the fastest route need not be the best route. So that is I think a key takeaway for this session. And the focus is on revenue generation, and it is not just on reducing time, distance, or fuel. Now, coming to some use cases of all three: cost-centered to customer-centered, static routing to adaptive AI-led routing, distance minimization to commercial impact. So one is Amazon, guaranteed delivery windows. So Amazon is one company which actually puts the customer first, and that has clearly reflected in them being a used case study for a cost-centered to customer-centered approach. So because of which, what has happened, the outcome is high customer satisfaction, and you have growth in memberships to the Amazon platform, increased loyalty, despite the fact that your last mile cost is actually gone up. So despite the fact that last mile cost has gone up, your customer satisfaction rates have gone up. So that is cost-centered to customer-centered focus from Amazon. Zomato, if you see, again, Zomato, Swiggy, all these instant food delivery companies are actually leading the adaptive AI-led routing race. And because of which, what is the outcome that has happened? There is a 20 to 25% reduction in delays. So instant food is something where you actually cannot afford that, and 20 to 25% reduction has happened in peak hour delays, fewer cancellations, and again improved customer service. The third example, the third use case study is Hindustan Lever, where it is prioritizing high value outlets. So if Hindustan Lever is, let us say, supplying to Reliance Retail, let us say in a Bangalore, or let us say a Bombay or a Chennai, it has categorized the outlets into A, B, C, and it prioritizes high value outlets. So which means it tells its suppliers, so let us first look at servicing these outlets first, or these distributors first. So instead of outlets, it could be the distributors. So the distributors which Hindustan Unilever is supplying to, they could be classified as ABC. So high value distributors get serviced first. So definitely looking at the commercial impact of the whole thing rather than just distance minimization. So what has happened? The outcome because of that is 12 to 15% growth in premium category sales, which are carried by these A category distributors or A category stores. Reduce stockouts and in priority outlets, which is very important, which is a very important metric, and higher route profitability. So the route that they take ensures that after all the costs are factored in, you still have a high profitability. So the core idea of route optimization is to minimize time, distance, fuel, cost, address practical constraints, and of course, very importantly, balance efficiency with business logic. Now, there are some direct constraints in routing. There are some indirect constraints in routing. What are the direct constraints which you have already talked about? Delivery windows, vehicle load capacity, traffic patterns, service time variability, fuel economics, and customer stock availability, customer service, and all that. So those are direct constraints. And like I said, the fastest route need not be the best route. Commercial priorities override pure efficiency. Premium outlets may be off route, but they still will be serviced first, even if the distance is high. And if supposing you're running a promotion in a particular outlet, that again, if you're running a promotion, a sales promotion in a particular outlet, that again would change the routing needs. So this is where we say that it is dynamic and it is not static. And this need not be again following the best route principle or the fastest route principle. It need not be following the fastest route principle. From an outlet point of view, some routes will favor A-class stores, high-potential territories, margin-heavy product points. Now, the performance metrics. Now, if I have to come to the performance metrics which are actually used by all these companies, whether it is FMCG companies or retailers or quick commerce or instant delivery platforms, would be one, most importantly, on-time delivery, right? So if I have ordered for something, I expect it on time. So that is OTT. That is the most important metric. And as a subdivision of OTT, there is something called OTIF, or on time in full. So if I have ordered 100 pieces, am I getting 100 pieces, or am I just getting 50 pieces? I'm getting the on time delivery, but I'm just getting 50% fill rate. So 50 out of 100, 50% fill rate. So my OTIF metric actually then scores a 0. So OTIF again as a subset of on-time delivery. Route adherence, how much of a deviation is there from your actually optimized route or the route which has been suggested by the system. What is the average delivery time to a particular outlet? Distance traveled totally. We saw that in the traveling salesman problem. So what is the distance traveled on a particular beat? What is the first attempt delivery success rate? We see that with our B2C orders. So whenever somebody is actually trying to deliver something at home, the person may not be available. So the first attempt becomes a failure. So what is the first attempt delivery success rate? So that is a key performance metric. Vehicle and driver utilization rates. So is the vehicle running to full capacity? Are we utilizing the driver, or are we utilizing the salesman fully for the complete working hours? What is the fuel efficiency on the particular route which the vehicle has taken? What is the comparison? Is there a difference? Again, this again relates to your second point, which is the route adherence. Is there a difference between planned and actual routes? And if so, how much? What is the revenue per route? So this is something. So this is something what I was talking about. Till a few years back, this was not the case. We were not talking about revenues per se uh, as a benefit of route optimization. It was only cost, it was only time, it was only efficiency. But now, if you see the revenue, how much revenue am I getting? So, which means if I've got X number of outlets on a particular route, how much of revenue do I get from those outlets? And as revenue as a factor, as a function of cost, or revenue divided by cost, what is my ratio? So what is my revenue per route is an important metric which is actually which is now being used by all these major companies. Again, revenue per route is actually again linked to customer experience metrics, so which means your customer satisfaction, your customer loyalty points, your customer feedback. All these things are actually becoming very important performance metrics. And finally, any kind of untoward incident or exceptions which always happen in this kind of a day-to-day delivery. So when you are actually, if you are going to service, let's take the example of Reliance Retail. If you're going to service 18,000 stores on a day-to-day basis, obviously there has to be some issue or the other cropping up in at least one or two of those stores. So what are those exceptions? What are the incidents, and how are they being handled? So these are the performance metrics which are used by companies. Now, till now, what I was talking about are the direct factors which affect route optimization. But I have now come out with, or I would like to elaborate or discuss on certain indirect factors which also affect route optimization. There are two of them which I would explain in a little bit of detail. So the first factor is the product category. Now, this is not directly linked to route optimization. When I say directly linked, it has nothing to do with the vehicle or anything like that, but it is purely a function of the kind of product which is actually being delivered. Now, if you see over here, there are 5 kinds of products which are being mentioned. So, perishables, which is basically a fruits and vegetables. Again, I'm talking from a retail point of view, a food and grocery retail point of view. Perishables, which means your fruits and vegetables, your uh, dairy products, your products with expiry, which is probably less than a month, less than 2 months. Perishables need speed. So that is the major factor to be considered when you're transporting perishables. When it comes to FMCG, it's a volume-driven business. FMCG needs coverage, so it needs more and more outlets. It's not so much a factor of perishability, but it's actually a factor of how many outlets are you able to cover. And the third category is high-value goods, which would be your like your electronics, your mobile phones, your high-end laptops, systems, which need reliability while you're transporting. Jewelry, right? Uh, Bulky goods need capacity planning, so you need the kind of truck which you'll be using for these kind of goods. So that is actually determined by the product category type. And finally, promotional goods. So if you have a promotion which does not happen 365 days a year, a promotion is probably happening only, let us say, in 1 week. It happens, let us say, 1 week every month. So that particular week probably would need a very dynamic kind of a changed, adaptive kind of a rerouting of the whole process or uh, planning. So 5 types of products and 5 types of products requiring with different needs. So this actually indirectly affects route optimization. Now, if I have to now give you a detailed example of all these products, so perishables and cold chain, which includes the dairy, ice cream, fresh produce, short shelf life, temperature sensitive. So you have to prioritize shortest time routes. Speed is a factor. Early day visits, early in the morning, preferably, and you need to track this in real time. And obviously, there has to be a cold chain compliance, which is obviously goes without saying. High frequency FMCG items like your staples, your beverages, your groceries, your snacks, fast turnover requires frequent replenishment. So again, you need to have maximum outlet coverage. Frequency of coverage is high. Again, ABC priority routing comes into play. Optimized beat routes and reduced stockouts. High value, low volume like pharma, electronics, chemicals. Again, risks involved and requires a separate set of procedures to design the route for that. And likewise, you have promotion driven categories. You have got bulk heavy goods, and you've got emergency response supplies like life saving medicines, or hospital items. So, this is just to give you a deep dive into each of the product categories and how the needs actually vary across the different product categories. Okay. Now, this is again, I'm taking another example of two product categories. One is from grocery and one is from pharma. And how do they differ based on frequency, based on time sensitivity, based on load characteristics, and based on priority outlets. So again, if you look at groceries, high frequency delivery, so which means replenishment is high, gets consumed faster. These are everyday essentials. These are perishable items. There's a rapid turnover. And if you see quick commerce players like your Zepto, your Blinkit, your Big Basket, all these players will be running at least 4 to 6 delivery cycles in a location per day, right? So that is what uh, that product actually does to your route optimization or your route planning. Whereas if you look at pharma, the frequency of delivery is very less compared to groceries. It is more predictable schedules. Pharmacies, hospital distributors often follow a daily or an alternate day or an alternate or maybe a once in a week delivery cycle. Emergency orders may be there, but those are like few and far in between. But the main point I'm trying to make is that there is a difference between both the categories when you actually come to frequency, and likewise when you come to the time sensitivity of the product, the load characteristics of the product, and which means the size of the product and the priority outlets to which it is serviced. The second indirect factor which I want to highlight with route optimization is ITR. Now, before I come to ITR, obviously we need to know what is ITR. Some of you may know what is ITR. It is the inventory turnover ratio. It is actually a direct, it is kind of linked to the previous uh, factor, which is the product type. So inventory turnover ratio is nothing but your, if you have to put it in a definition form, it is the average, your average cost of goods sold or your COGS to your average inventory investment. And it is a widely used measure of effectiveness of inventory management. Now, higher the ratio, what does ITR mean? So higher the ratio, it implies better usage of inventory. Now, FMCG products, if you see, will have a high ITR purely because of the fact that the consumption is high, your stock rotation is very high in FMCG products, especially in the food products. So, and at the same time, product taking a long time to manufacture or sell will have a lower ITR. So, ITR improves. So, how does route optimization actually impact ITR? That is what I'm coming to. ITR improves when route optimization actually enhances your service frequency, it reduces stockouts, it increases the velocity of product movement across the network. So when all these things happen, automatically what happens, your ITR goes up. And like we discussed, higher the ITR, the better is your inventory management. And better is the health of that particular store and better is the health of that retail chain. So in other words, indirectly, route optimization encourages higher rotation of inventory. Hence, it encourages higher ITR. Okay, so that is another indirect factor which I wanted to highlight, which is a key factor, especially when you come to FMCG and retail. So again, optimized routes ensure stores are visited more frequently, orders are delivered on time, stockouts are minimized. When routes are inefficient, what happens? High selling outlets run out of stock. Stockouts is a big crime as far as retail sector is concerned. So stockouts, lower sales, slow down inventory turnover. So that is something which we actually frequently experience in the retail sector. So optimizing this obviously ensures that your priority outlets at least get those high demand outlets, get the high demand uh, uh, SKUs and products on time. Okay. The route optimization also prioritizes A-class stores, and again, this leads to improving ITR. Now, better routing makes delivery cycles predictable. Now, predictability allows companies to reduce excess inventory. So, which means if you know that your route, if you have a route going on a particular day, particular time, you will know exactly how much quantity to keep in that particular store, or how much quantity to. So that is actually a decision enabler for the person, for the retailer, without actually stocking up on inventory and then increasing your inventory holding costs. Yeah. So, and then again, so if you are going by the ITR formula, if your average inventory is low, again, it automatically pushes up your inventory turnover ratio. So, net, what we are seeing is route optimization has this positive effect on the ITR and in turn on store performance. Now, good routing also ensures timely deliveries, lower buffer stock, and again, both of these actually more frequent replenishment. These are all drivers of inventory performance. Okay, so this is basically an outcome-based table on ITR and how route optimization actually impacts the ITR per se. So what we need to know is faster replenishment, high demand SKUs always available, A-class outlets getting uh, uh, serviced on time, lower buffer stock. Actually, all of these actually pushes up your ITR, which is always a welcome metric. ITR is a welcome metric when it comes to store performance. Now, having said that, I'll come to the final part of the presentation, which is the AI in route optimization. So, having said all this, having given you the backdrop as to why we need route optimization, what are the factors which influence route optimization, what are the direct factors and what are the indirect factors, I will come to AI in route optimization. Now, here again, it's more of a theoretical approach which I am taking. I would not be explaining anything practically to you. I'll probably be listing out some of the tools which are being used. And towards the end, if you get time, we'll also show you a demo of how an APIs are used to actually design an AI model. Okay, so we'll see that video in a while. So I was just looking up some literature on this AI in optimization, in route optimization. This is what I came out with. So this is one of the papers which talks about how reinforcement learning, neural networks, genetic algorithms. Again, this is getting a bit technical. AI-powered route optimization adapts to real-time traffic and demand data. So there is a 2025 dated paper on this, and many more such papers are available. Now, predictive AI actually, what does it do? How does it help? What are the capabilities? It actually helps in predicting demand per outlet for each store. It forecasts peak periods of the season, let us say festive season, or let us say summer. What are the kind of products that would sell? And based on obviously sales data, past sales data, it is able to predict uh, these things and auto generate. And based on that, it is able to auto generate optimal routes. And also, and this is something which I actually got from the industry. So identifying non-performing routes. So what AI does is, if you remember what I said, route optimization, if you do on an automated platform, or if you use AI, it is done regularly. It is done once in a quarter. And once in a quarter, when they do it, when they run that software, it also identifies the non-performing routes. So that actually helps the company in rationalizing routes, just like in a retail environment, you rationalize SKUs, you rationalize non-performing SKUs which are not contributing to sale or margin. Likewise, you actually rationalize or remove these non-performing routes, and this is found out using this run. The technical term which they use is run. So they run the software on a quarterly basis, and not only do they auto generate the optimal routes, but they also identify the non-performing routes. Now, benefits of AI-based route optimization software, I think it's pretty self-explanatory. Reduced cases of late deliveries, enhanced fleet utilization of the trucks, fuel and cost savings, of course, more accurate expected time of arrival (ETA), improved safety, better productivity, proof of delivery, again increased revenue. So here again you have an increased revenue uh, uh, concept which is coming in, and it is not just about reducing cost. If you look at the AI routing workflow, you give data inputs, which then generates a demand forecast, and then all the constraints which we discussed about earlier are actually inputted into that model, and then a route is generated out of which you evaluate whether it is giving you the appropriate whether those metrics are actually uh, uh, doing optimally well based on what you had actually planned. So this is how the workflow actually uh, runs. And some of the examples of constraints which we input as which we give as an input into the model is: one is the outlet sales value, two, just to give you a few examples, geographic location, traffic, capacity of the vehicles, and so on and so forth. Again, this is again another uh, flow of how an AI route optimization system works. So it starts with data collection, analysis, route planning, real-time adjustments, execution, and of course, evaluation or tracking of the performance. Now, what I'm going to show you here is a demo of a platform which has already inbuilt uh, a workflow, and it has got certain data points which are digitized. So this is a platform. It is in Google Cloud, and it is a platform with inbuilt workflows and with data points, which the past data points which have been taken and which have been digitized and given as an input to this model. So let us see. It is a 10-minute long video. Let us see how they do it here.
Sir, are you playing any video?
Yes, I am playing a video.
Okay.
Oh, sorry. Yeah.
Sir, if you can share the link on the chat box.
Pardon me?
Sir, I guess it's an online video. So if you can share the link on the chat box, like it is very small, no? So it is difficult for us to
Okay,
understand what's going
it is actually inbuilt in. Okay, I will share the link. I'll share the link in the chat box. Yes, it is inbuilt into PowerPoint. I'll
Thank
do
you,
that
sir.
at the end of the thing.
Jai Shri Ram.
Okay, so most of it would have probably been a bit technical in nature, but then the ultimate point is how are they actually using the information to create a route using Google Maps. So that was the basic idea behind this demo. And if you see, that is what industry also practitioners also are using. Google Maps is actually the gold standard when it actually comes to creating routes and using APIs to create all these routes for their applications and websites. Now, some of the organizations which are dealing in automated route optimization, uh, uh, these are the ones. I'll anyway share this presentation with you. So these are some of the companies, SFA, Salesforce automation companies, and they are into different verticals. And if you see, predominantly FMCG, pharma, retail, consumer goods, and so Bizom is the app or the product whose expert I had a chat with. So they are into FMCG, they are into beverages, they are into foods, and they use this on a daily basis. Okay, some of the other tools which I could pick up. Again, this can be shared with you. You can look it up in your whenever you're free. So Rhythm is another proprietary software of Bizome, which we just discussed. So there are others. There are quite a lot of apps and tools which are available to actually optimize routes. And Google, of course, Google Map is actually a standard part of this whole system. Now, just to conclude, I would like to conclude with industry view. And the industry view, when I spoke to the expert, so there was a very startling revelation. Route optimization is actually the last 20% of the whole work. The network itself has to be in proper shape. So the first 80% is the network itself. And then comes the route optimization part. So if the network is not good, uh, the routing won't be good. So that is basically what what I'm trying to convey. A badly designed network, uh, if you do not have the proper points, the transit points, if your geography is not properly uh, planned and it is not mapped, or the mode of transportation does not match the profile of the product or the company. So even the smartest optimizer solution would also fail. So this is what the industry expert has told me, and this is exactly his words. Uh, Again, continuing with the industry view, network first, routing later, the primary legs as the backbone. So in logistics, a leg is the distinct segment of shipment's journey between two defined points. Geography important, mode of transportation important, and routing must be contextual, like we discussed earlier. It is not just based on distance or shortest distance, and it must be dynamic, keeping into account the constraints which we have already discussed earlier. Expected time of arrival is very important, and it outweighs the theory that we do on paper or the planning which we do on paper. And judgment at the end, human judgment is also an important element. Now, a final point which needs to be mentioned here is that routing needs good, clean, real-world maps or data from good, clean, real-world maps, and that can only be provided by Google. So that is the gold standard right now. And this is again quote unquote from the industry expert. These are some of the references which I have used, and yeah, thank you for your time. I hope it was a useful session. I think the video which we just showed has been shared in the chat box. And I will share the slides also with you. I mean, it was quite a text-heavy set of slides. So that will also be shared. Apologies if that demo got a bit too technical, but I think it was very important to actually show the complexity behind all the outward the interface which we see.
Thank you, George sir, for your session, for bringing in
Thank you, ma'am.
many real-world insights as well as industry perspectives to this today's discussion. Thank you so much, sir.
Thank you, ma'am. Thank you so much for the opportunity.
Thank you. Dear participants, I've shared the feedback form for the 4th session. Please do fill up the feedback form. And once again, thank you to all the participants for being with us for the second day of the AICTE online FDP. Thank you and wish you a wonderful day. Thank you all.
Thank you, ma'am.
Thank you.
Thank you, ma'am.